Now it is time to look at an example with positive velocity and negative acceleration. All right, so what is the negative acceleration going to do to the positive velocity? So a bottle rocket is shot up in the air. The ground is going to be our zero, our reference point. That's going to be the zero on the position time graph. And it's going to be shot up with a negative acceleration. There you go. All right, so you see that the amount it moves every second is getting smaller, indicating a slowdown. The position numbers are right here, and we can find the velocity by finding the difference in the position numbers every second. So that comes 35, 25, 15, and 5. So you see the velocity is positive because the rocket is moving away from the ground, and the ground is the reference point. So it's moving in a forward direction. However, the velocity is getting smaller, and let's see what that means to the acceleration. Acceleration is going to be the change in the velocity. From 35 to 25, you have to go down 10. Then from 25 to 15, you go down another 10. So you can see that the acceleration is negative. So positive velocity and negative acceleration, you get a slow down. Right? It's slowing down as it moves away from zero. What would the position versus time graph look like? All right, so we have a curl downwards, which indicates a negative acceleration, but you do have the line moving away from zero, which indicates a positive velocity. In the beginning, the line is steeper because you have a faster speed. At the end, the line is flatter because you have a slower speed. What does the velocity versus time graph look like? So imagine you just plotted these velocity numbers in red, and because you're going in between the two different times, you put them right in between those times. Draw a straight line through it. All right, and so that is your velocity versus time graph. You can see that it's positive, but it's getting closer to zero as it slows down. The slope of this line should equal the acceleration. The slope is rise over run. Just looking at this graph, it looks like the rise is negative 40 and the run is 4. Negative 40 over 4 is negative 10, which is exactly what we got when we just looked at the numbers. So the acceleration is minus 10, right? And so is the slope of the velocity time graph. Okay, so a positive velocity and a negative acceleration will always give us a slow down. It'll be a slow down as the object moves away from the reference point.